Rinehart. I am the Chief Enterprise Security Architect for UnitedHealth Group. The responsibilities typically are a very strategic sort of role in sort of defining the transformational sort of approach for security and engineering at the company, and generally those sorts of responsibilities. So chaos engineering represents sort of what I like to call, I like to break down security instrumentation into two domains. Two domains being testing and experimentation. Now, testing is the validation or verification of something you already know. It could be a CVE, it could be a particular vulnerability type, it could be a pattern, it could be a signature. Those are typically more of the security pieces. There's also experimentation. That's where chaos engineering falls in, is that it's the idea is to derive new information that you did not know. Is try to figure out more of what was going on that you didn't know about, and how that may add value into your approach. So there are some new methods with in adversity testing. Is sort of taking the role of the adversary into how we do testing in software, and there's a whole vein of that really made popular by Uber engineering, the folks at Uber and the folks at Intuit. But chaos engineering is really it comes from the idea of introducing turbulent conditions into a system, determine how the system will react to those conditions when it's running. And it's the same sort of principle when applied to security. It's introducing sort of activities that so for example, if your system stopped logging, would you be able to detect that when that happens? How long would it take you to detect it? How long would it take you to remediate it? And what would that mean if you may not be able to detect the problems you think you can detect if they stop logging? So it's the idea of not assuming that you can do that. It's the idea of injecting that failure into the system, and then learning and improving the system through that. The point I would make about operational instrumentation is that the existing methods in testing that we use today still are extremely valuable. The more objective instrumentation that we can get to tell us what is going on, the more data we can put around the context of a problem and learn from that, I think is really valuable. Chaos engineering is just another new avenue for when it comes to distributed systems. Distributed systems are becoming what is known as a complex adaptive system. It's very similar to how the human body operates. Is that they're designed with such complexity and how they interact with each other, and at the rate at which we evolve them, it's becoming very difficult without constant instrumentation and challenges to the system. Without that additional context information, we are in a situation where we really don't understand what's happening with our own systems, and that can be scary, because without that we slowly drift into failure. Obviously, chaos engineering is a huge mechanism for learning, but I'm going to focus more on experimentation, because I think that encouraging your teams to experiment, to evolve their skills, to encouraging folks to actually try things and learn. I think it was Google that originally introduced the idea of 20% time. Atlassian has 10% time. But it's the idea of giving employees, your staff, the 10% or 20% of time to explore new technologies like containers, or if they have questions about it, they can, having that context of how something actually works really helps you, whether you're an auditor, whether you're in compliance, or you're actually doing the engineering. You understand more what the right questions to ask from an auditor perspective. You may understand or have more empathy for who you're dealing with because you tried to implement those technologies. Or you also may be able to better help a partner. I think it's important to drive and feed the curiosity of employees, but incentivize it. Chaos engineering is one way of doing that. Is encouraging security practitioners, professionals to join in those exercises with their product partners and helping to drive understanding empathy with the teams. So from a formal education perspective, the ability to code has become more and more in need than ever before. That's actually one thing we did at UnitedHealth Group, and a lot of people found that interesting that we did this. But we decided to challenge all of our employees as part of development, our security employees, to learn Python this year. And the results we got out of that were so rewarding. It wasn't just about, the point of it was not to rebrand everyone as a coder. The underlying theme behind it was to break down the fear of it. Right, is that many people fear the ones and the zeros and the coding, and they think it's all ones and zeros, but it's not, right? Coding is learning to write software, to write code is really more quality of thought than it is syntax. Is that once you get past the basics of for loops, and that's where a lot of people get caught up, is some of the looping and the, but once you get that down, it's hard to understand. Really, it's quality of thought. And a lot of people, whether you're a coder or not, you go back after 20 years in the business, you may find that you're pretty good at it. It's because you're able to think through levels of your own experience and drive out value. And we found out, one, that was the case. We got a lot of great little snippets of code. It started off somewhat, there's always a maturity in learning it, but we got so much value out of people trying and learning. But it wasn't about the coding. It was about breaking down fear of it. And also you drive an empathy with the other teams writing software. Furthermore, when the world is of our products, name a company name a product that you're a customer of today that is not driven by software or by computers. And it's important when we're doing that to security professionals to understand the products that are being built and serving things. We typically have only interacted through the lens of a testing type of platform or an audit. And I think we get it into, we can drive a new level of understanding of our own security by understanding how to code, right? Understanding what software teams are, how they're innovating and driving value for the company. I think we can be closer and closer to that. We can drive more value. If companies want to transform the engineering, the people matter, you have to. And if you want top talent, you have to pay for it, right? And it has to be equal. I've struggled with human capital surveys for years. No matter where I'm an executive, I always run into, when I want to pay somebody what I feel is more market, I'm challenged with what I know to be market as being someone in the field that has matured through it and kind of knows what the pays are. I get challenged always with surveys and things like that. And I would ask that human capital professionals align themselves where the company wants to go, because a lot of times where the company wants to go it requires that the engineering meet them along the way. And I would say if there's questions about that, look at what Amazon has done, look at what Netflix has done, look at what Google has done, look at other companies like Target, or look at the companies that represent where your company wants to be, and look and see how they approach what they pay for their engineers, who they hire. I would say use that as your survey more than using a broad survey of titles and numbers. I think we are ill-equipped, and I think we're outgunned when it comes to an emerging problem on the horizon. As humans, we tend to solve one problem and create many more. And today's world of engineering and modern technology is no different. I believe with the advent of cloud computing, microservice environments, continuous delivery, those are all great things in delivering new value to customers quickly and responding to market demands. But I believe what has happened is we've created a new era of problem, in that all those things combined have allowed our systems to grow to a point where they are indicative of something called a complex adaptive system, which means that complex adaptive systems have nonlinear outcomes. What that means is cause does not equal effect necessarily. Because of the nature of how things interact with each other and the relationships with them, you have thousands of microservices now. They're changing all the time. There's different teams associated with them. it's becoming very difficult to understand why these unpredictable things are happening. And what I mean by outgunned is we're not prepared for that problem. Is that we are focusing on those three things individually: continuous delivery. That's also kind of like DevOps, CI/CD is another. But continuous delivery, cloud computing, and microservices, and we end up creating these systems that look very much like a human body and how they interact. Human body or weather patterns, financial markets. It's getting to a point where it's non-Newtonian physics, which for every action is equal or opposite reaction is a good example of one of Newton's laws. That's not necessarily true of the human body. An action with a medicine does not mean if you take some medicine does not mean it directly solves the problem. You may in fact actually create new ones, right? That's what their side effects. Same thing with engineering. Is that our systems are not working like that? So that's why chaos engineering and things like observability. If we can't necessarily stop it or prevent it, we need to try to understand what's going on so we can learn and prevent those types of bad outcomes from happening.